How's it going, ladies and gentlemen? Mr. Donnie here, and we're going to look at naming covalent compounds. I don't know if you guys have heard about dihydrogen monoxide. It's used in pesticides, and it's getting into our foods. Accidental inhalation can result in death. All right, and we're going to talk about, well, what the heck is this stuff? All right, so first things first, which element do we write first if we have a formula? For example, if we had carbon and oxygen bonding together, when we write the formula, why is it CO2 and not O2C? Why do we put the C first? Generally speaking, we always put the less electronegative element as the first element that we write. So if you remember our trends for electronegativity, it is the greatest towards the top and towards the right. So if we're looking at carbon and oxygen, well, we know carbon's the less electronegative element, so we put carbon first in our formula. If we look at HF, hydrogen fluoride, same deal, right? Hydrogen's way over here, it's not even listed, right? And fluorine is the most electronegative element that we got, so hydrogen goes first. Now, if we're looking between nitrogen and oxygen, same deal. All right, well, I know oxygen's more electronegative, nitrogen's less electronegative, so we got to put the nitrogen first, so it'll be NO2 and not the other way around. So we have two ways of naming things. We got the stock system, which you guys probably seen already from what we did with the ionic compounds when we used the Roman numeral, and the Roman numeral is the charge. And then there's the Greek system, where we use Greek prefixes to specify how many of each element there are. And you will never use both Greek prefixes and Roman numerals. Just remember, Greeks and Romans, they didn't get along, right? You're not going to have both of them. So let's take a look at what students have referred to as the easy way of naming things, and it's using the Greek prefixes. So the first name is just going to be the prefix for how many of that nonmetal you have, plus the nonmetal name. So the prefixes that we got are mono for one, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. You've probably seen some of them before, like triangle, but I forget, penta, what's that one, the shape? Pentagon, hexagon, octagon, right? So you've seen the prefixes before. So the first name is just prefix, nonmetal, and the last name is, again, the prefix, the nonmetal root, plus the ID ending, the "ide" ending. And we also don't need to say mono for the first element. Like if we had CO2, we don't have to say monocarbon. This is just for that first element. If you only have one of them, you just say its name. It would just be carbon or whatever element it is. So let's take a look at some examples. So here I got carbon. There's only one of them. I don't need to say carbon or monocarbon because it's the first element. Next one's oxygen. There's only one of them, so it's monoxide. You guys probably heard of this. It's a deadly gas because it will bind to your blood and not let go of it. So it can't carry around oxygen. You slowly more or less suffocate to death. It's not good. Don't recommend it. Next example, we got CO2. So again, one carbon, so we just say carbon. It's got two oxygens, so the prefix for two is di, so it's carbon dioxide. This is stuff that we breathe out. All right, again, carbon, only one of them, so we just say carbon. And then we got four chlorines. So the prefix for four is tetra. Now, it's not going to be chlorine, it's going to change to chloride. So this would be carbon tetrachloride. First element, nitrogen, only one of them, so we just say nitrogen. Next element is an oxygen, and there's one of them, so we got to say monoxide. All right, SO2, sulfur, only one of them, so we don't need a prefix for that first element. Two oxygens, we say dioxide. Phosphorus, PCl5. So phosphorus, only one of them. First element, we don't need to say mono. So phosphorus, I'm going to run out of room. How do we say 5? Pentachloride. Carbon, CS2. So we got carbon, disulfide. N2O, finally an example where we don't have just one of that first element. So how do we say we have two nitrogens? We'll say dinitrogen. Now notice you don't have to change that suffix for that first element. It's just dinitrogen, two of whatever that element is. And how do we say one oxygen? Monoxide. Now we have one nitrogen and two oxygens. So it'll just be nitrogen dioxide. Next example, we got SO3. How do we say one sulfur? You just say sulfur. How do we say three? Tri. Root of that nonmetal, ox, and end in ide. So sulfur trioxide. Now the SOC system we've used before using naming ionic compounds. We, remember the Roman numeral is the charge. So we first got to figure out how many of each element are in the molecule by looking at the charges. Right? So same compounds named using the different system. Well, I got C and then O. Well, what the heck? What's the charge of C? I don't know. I'm freaking out. You just got to calm down, take a breath, and remember that this element, the last element in the formula, is always its first listed charge on the periodic table. Now, I remember a lot of these off the top of my head. If you don't, just look on the periodic table and go oxygen. Well, I know oxygen has to have a -2. And that whole thing has a charge of 0, so that carbon must have a +2. So going to name it, it would be carbon 2, Roman numeral 2, oxide. Next one, we got to figure out the charge of the carbon. If I have two oxygens, each -2, that tells me I got a -4 overall, which means I must have a +4. And I only got one carbon, so that carbon has to be +4. So the name for this would be carbon, Roman numeral 4, IV, oxide. CCl4, same process. Look up, well, what is chlorine's charge? It's -1. There's 4 of them, so there's a -4. So carbon must be +4. So it'll be, again, carbon 4, IV. Now, chloride. Notice how I haven't prefixes, any of the Greek prefixes, because Greeks and Romans don't get along. You don't put both. It's one or the other. So now we got nitrogen, NO. Look up oxygen, it's -2. So nitrogen must be +2. So the name would just be nitrogen 2, Roman numeral 2, oxide. All right, so I'm going to kind of go fast right here. Each oxygen's -2. We got 2 of them, so that's -4 overall, which means sulfur has to be +4. So the name for it would be sulfur 4, Roman numeral 4, IV, oxide. PCl5, each chlorine's -1. I got 5 of them, so it must be a -5 overall. So I need a +5 to cancel it out, and I only got 1 phosphorus, so it must be a total of +5. So it'll be phosphorus, Roman numeral 5, which is a V, chloride. CS2, I look up sulfur's charge, it's -2. There's 2 of them, so that gives me a -4, which means I need a +4 to cancel it out. So the whole thing is 0. So that carbon has to be a total of +4. So to have carbon, Roman numeral 4, IV, sulfide. N2O, well, each oxygen is -2. And there's only one of them, so I got a -2 overall, which means I must have a +2 to cancel it out. Now there's 2 nitrogens, giving me a total of +2. So what's the charge of each nitrogen have to be? +1, right? 2 divided by 2 gives me 1 on each. So the name would be nitrogen 1, Roman numeral 1, I, oxide. Now remember, the Roman numeral is the charge for each of those elements. Each of those atoms have a charge of +1, so I use a Roman numeral 1. NO2, well, I know each oxygen's -2, so I got a -4. Means I must have a +4 from one nitrogen, so the nitrogen has to be a charge of 4. So the name would be nitrogen, Roman numeral 4, IV, oxide. SO3, again, -2, there's 3 of them, so I got a -6 overall, means I need a +6. 1 sulfur means that has to be a total +6. So I get sulfur, Roman numeral 6, which is VI, oxide. Cool. So let's try going from the name to the formula. Let's do a little practice going the other way. So this is why students call this the easy way, right? Because we got chlorine, so it tells me I got 1 chlorine. Dioxide, telling me that I got 2 oxygens. So the formula is just ClO2. Dichlorine, so that means I got Cl2 heptaoxide. So I got oxygen, I got 7 of them. So that's the formula right there. Carbon 4 iodide. All right, so now here you got to remember that the Roman numeral is the charge. So we know that carbon has a charge of +4, and iodide, I look up on the reference table. I use its first listed charge, it's -1. So what would the formula have to be? You can do the trick of, well, let me switch these charges so I know how many of each I need, and then simplify. Or you can think about it, well, if I have a +4 and I've got -1s, I'm going to need 4 of those -1s to cancel out the +4. The formula would be Ci4. Dinitrogen, that's N2. Pentoxide, that's O5. Sulfur tetra, you got to remember tetra means 4, so SF4. Carbon 2, remember the Roman numeral is the charge, so carbon +2, oxide. I look up, well, what's the charge of oxygen? It's -2. So I know I'm going to have 1 carbon and 1 oxygen. Nitrogen 2, oxide. I look up oxygen, still -2, so the formula will be NO. Sulfur 6, so I know S, oh, crud. Forward. Sorry about that. S +6, fluoride. Well, I look up the charge of fluoride, it's -1, so the formula would have to be SF6. Phosphorus 5, so I got P with a +5 charge. Bromide, I look up bromide's charge, it's -1 each. So the formula would be PBr5. Dihydrogen monoxide, going back to that thing that I told you about. OMG, it's in pesticides. If you accidentally inhale it, you die. It's getting in our foods. What are we going to do? It's the most horrible thing in the world. It's everywhere. It's unregulated. It's getting into our groundwater. Well, let's calm down. All those things are true. Dihydrogen monoxide. So I got 2 hydrogens. Mon, 1 oxygen. Yep. It's just water. If you accidentally inhale water, you die. It's called drowning. Don't do it. All right, so I will see you in class. Hope you found that helpful.